Okay folks, so today's project is to replace the AC heating element in our trailer's refrigerator. The model is a Dometic. It's DM2652LBX, and after it works just fine on propane. We've got DC or AC power hooked up to it, shore power, but it just quit working on AC. So the fridge would get cool and the freezer would freeze on propane, but because the heating element died on this thing, then we had to buy a replacement. This is the old one, and as you can tell, it's kind of crappy looking, hard to see. It's not shiny anymore like it was up here. This is the new one, and if you compare them side by side, you can see there is a significant difference in the two. So basically what I did to ascertain that there was a problem with this, that it had burnt out, it's just like a heating element in your household water heater. Basically what I did was took my ohm meter here and I got it set to tone, and you pull these little plugs off the circuit board and you plug your ohm meter in here. Let's see if I can get them in here so y'all can see it. Hard to do this with the old cell phone, folks, sorry. Okay, so we've got our probes plugged into our ohm meter, and you can see we're reading 0 resistance, which means that thing's burnt out. So when we plug it into our new one, okay, so we're back. And the reason it was reading 0 on the old probe was because I had my leads hooked up incorrectly. I had it hooked up over here. I should have had it over here to test for ohms, but at any rate, I've got them plugged in right there into the old one, and you can see it's reading 0 resistance, so it's burnt out. So we're going to plug it into the new one. You'll see here in just a moment that we're going to get resistance. Okay, so we're getting a resistance of 48.5, 48.1, 48, and it's toning out, so our good one is good. Obviously, it's brand new. Alright, so we had to yank the fridge out in order to get to our heating element here for the fridge, and it was fairly straightforward. You had to unhook the propane. I capped it off with a little bit of tape to keep trash from getting in there. I capped off the propane right here where it goes in with a little tape to keep trash from going in. Disconnected a couple of things, disconnected the AC power. There was that line out there is basically 12 volt coming off the converter, or excuse me, the inverter, and it plugs in right here into those two things right there. These right here, they just plugged up here, and I got them out of the way so that I could unhook the propane. But other than that, there was 2 screws at the bottom. There was one right here, one right here. There were 2 inside the fridge that you pull the top cap off, and one went up into here and one went up into here, and then on the front there were 2 screws. You will see them when you open the front door. They just screw right in there and right in there. So it was a fairly easy thing to pull out. Now what I would recommend, you see the blanket down there, I put the blanket out so that I could bring it out across here without scratching up my faux wood surface here, and find something that is the same height as from the floor up to this, so when you slide it out you're keeping it level, and it'll also make putting it back in. I just happen to have a cardboard box, a beehive box that we had laying around, and I put a piece of plywood on top of it to give it a little bit of sturdy flat surface while I worked on it. When I bought this, I bought it off of Amazon, and it's not OEM, obviously. I'll try to share a link to the Amazon site where I bought this, but a lot of the reviews said that it would not fit in there, that it was 5/1000ths of an inch thicker than the old one. Well, I took a gamble on it because I wanted to see if it was going to work or not. Basically, you got to unzip this metal right here. It just kind of clamps together. Push all that back in there, and you can see where it just kind of clamps together. That was sort of the booger of the whole project, was getting this thing unzipped. But at any rate, I want to show the world that this thing does fit in there fairly nicely without a lot of resistance. Let me find the space where it goes into. Oh, got to get our little cover here to put on. Okay, put it on the correct way, Harry. So that just goes on so that it provides cover in this blank spot. At any rate, it slides down into a little hole in here. Let me find the correct spot for it. Okay, there it is. And you just got to get it straight up and down. And you can see, with just a little bit of twisting, it just slid right in. There was no forcing it. There was no pounding on it. Wasn't a lot of problem. The old one coming out, because it was somewhat corroded, that was sort of a booger to get out. I had to twist and pull and twist and pull. Not a great deal of force, but nonetheless, it was a whole lot harder getting this one out than it was getting that one in. And you can see it moves fairly easily. So, hey, I don't believe the reviews on Amazon about that being too tight. Alright, so I've gotten the metal zipped back up together, and I'll tell you what, initially it was a pain in the butt trying to get all of this put back together, because when you pop it loose, it wants to spring out. And so you're sitting here trying to hold this together with one hand while you're crimping it together with a pair of pliers with the other hand. And I found that to be very difficult. So I hit upon creating a tourniquet, and basically all I did was just take it's actually a ratchet strap, the long end of it, and I just shoved it in there and twisted it around a couple of times, and it pulled that metal together so that all I had to do was just sit there and kind of push it in with one hand, and it hooked together, and then I crimped it with my my pliers, and I'd slide this down and get another section of it, tourniquet, and it worked great. Once I figured that out, using the tourniquet as my clamp to pull things together, that worked out. So here we are. We've got the new heating element installed. We're getting ready to shove this back in there, but before I do that, I want to install another fan. This is the one that came from the factory, and basically what happens is this draws air up to these fins. These are the cooling fins, and I want to install another one somewhere along in here perhaps, that will also draw that much more air up and help it cool down that much faster. This is really important when you're stuck out there and there's no shade trees and your poor little fridge is just sitting there struggling mightily to keep itself cooled down. An ammonia evaporative fridge goes up there, and those fins cool down the ammonia, and that's what creates cool for the fridge inside. So I've got a bunch of these that I took out of some old desktops for this very purpose. I'm going to look at this to see what my voltage is. I'm guessing, I don't know, 12 volt, obviously, 3.39 amps. That's what I'm after. So I'm going to somehow or another hardwire this into probably this one right here. I don't think I'll draw too many amps and overload the circuit, but probably one more up there that will help cool this thing. I found on a free giveaway site on Facebook for my local area. I asked for anybody who had desktop computers that they were decommissioning And basically what I wanted out of those desktop computers were these fans. These come with 3 different wires. There were 2 fans in each computer. One, I don't know that you can see or not, but that is a 12 volt 0.17 amp. And this one is a 12 volt 0.2 amp. Right there and right there. This one has 3 wires on it. The yellow is low speed, the red is the hot, and the black is high speed. So I'm going to wind up cutting the yellow off because I don't want low speed. The white was just a neutral on this one, and I went ahead and cut it off. You can see right there. The red and the black, obviously hot and neutral. But I've got 2 of these big ones, the 0.17 amps, and 2 of these, the other ones out there at the workbench. And what I'm going to do is mount these, the 2 that are 0.2 amps, I'm going to mount them somewhere along in here to push the air, help push the air up past these fins, and then it'll blow back out the vent covers that you see right here. That's the top. The air enters from here and it gets exhausted out there. By cooling these fins off even more, you'll make it cooler inside the box. So the 0.2s are going to go inside in the back. These 0.7s, 0.17s, I'm going to put them on build a little frame and put them on the inside of the fridge to help circulate air inside. I'll draw power off of where the little light is. I'll just put the hot wire in between the light and the little bulb in there, and it'll draw power. The neutral, I'll alligator clip that to the fins inside, and bingo bango. The thing that I'm going to use, if you'll notice, there is a metal strap right here that is just screwed into the fridge, and it basically just holds the fan in place. I'm going to make one of those out of this right here. Yes, I love some boiled peanuts. So what I did was I cut both ends out. I've got my tin snips right here. I've already started cutting just to make sure that I could cut through it with those tin snips, and it's fairly easy. So I'm just going to create a little strap that I'll fashion around my fan right here. It's got the same little groovy things that'll hold in place. And there you go. Alright, so we're back. After cutting the can, I fashioned my little strappy thing out of it. Had to cut the can in the diameter, or around the can, the circumference, because the cutting it up and down just wasn't long enough. So basically what I did was I cut the straps long enough. I put those little screws in there just to hold the strap in there. It has absolutely no purpose other than keeping the strap from springing out. I'm going to fish the wires down through the back. In other words, this is going to go up against the back of the fridge like that, so I'm not using the wires, pinching them up against that sharp metal. I didn't want them being cut over time with vibration. I'm just going to run these little screws right here into it, and in each one I knocked a little hole in the strap with a nail. So let's see if we can get it mounted on there. Okay, we're back. I've bolted them in there, and I've wired them in. This right here is supposed to go into this. This is drawing power off of this up here. There's apparently a thermostat right here, and so power is coming in from the bottom here and coming out here, snakes all the way through all of this stuff. That's just extra wire, and comes here. And this was the let me find it. This was the thing that was powering this one fan right here. You can see the little wires, they're part of that bundle right there. And what I did was I just took all the fans and put them together. You heard them running. Basically what I had was a hot wire. I just jumpered it over here. But any rate, all of them are running. and it's pushing out a lot of air. This one was doing okay, but these right here, these two, man, they were kicking out the air also. So all three are really working, and I'm pleased with that. So now it's time to put the fridge back in and turn it on, and hopefully it'll all work. Okay, so the fridge has been running for a couple of days after our little fan installations, and so now we're going to do a temperature check on it to see where we are. I'm going to be using this digital thermometer, and we'll see what it says. I've got a thermometer hanging in there, but I think it's giving some false readings because it's reading below 32, 0 Celsius. So we'll use the digital and see what we got. All right. That's what the regular thermometer is reading, and I've got this set on the lowest set, or the warmest setting that you can have. That drink right there is reading 40. The ones down in the bottom, 49, really. Okay, so the bottom is the hottest. The back of the fridge, 50, 55, 56. That V8 sitting right there. The fins themselves. Interesting. And you can hear those fans kicking on and off. So, at any rate, this is the reading on the back of the freezer, same time. So we were getting plus 40s, now we're getting a 14 on, 12. We're getting a really, really cold down in the freezer itself. So this is good temps for the freezer. That bolt right there. Ooh, 3 degrees, 2 degrees. Wow, that's seriously cold. So I'm going to push this thermostat up to its coldest point, and we'll check it again in a little while, a day or so, and see what we're reading.